All right, the ones in the back are just slightly different than the ones we had just got done doing. But the only difference really is the fact that your growth and decay rates are going to be represented as percents versus an actual word like doubling, tripling, halving, what have you. So you still have your value of A. A is still going to represent your initial quantity. That isn't going to change. But now you've got this R. So R is going to represent your rate as a percent. So we're going to have to make sure we can convert percents in decimal form, which shouldn't be a problem. We'll practice that for certain. But then that means that that R is part of where B usually is. This is your B value. So what does this mean? Well, it should be kind of, make sense that we've got a plus and a minus here, thinking that's back to quadratics. Nope, has nothing to do with quadratics. But we have to make sure that growth is greater than 1 and decay is less than 1. So if we have a growth problem, to create our growth factor, we're going to do 1 plus our growth rate. And that should give us a value that's greater than 1. Whereas if we have a decay problem, we need our B value to be less than 1, so we're going to do 1 minus our decay rate. And that will get us right where we need to be. Your X value, most of the time in these problems, is time, some unit of measure of time. Okay. All right, so let's take a look. So we've got, you buy a house for $130,000. It appreciates. Appreciates is just another way to say increases in value, where if something depreciates, it's going to go down in value, 6% each year. Since we see that 6%, that's kind of your clue that you've got yourself a exponential function. And I want to know how much the house is going to be worth in 10 years. So growth or decay, appreciates meaning increases. This is a growth problem. My initial amount, $130,000. Now, here's where I have to be able to convert. So this is a growth problem. We're growing by 6%. We need to change that percent to a decimal. To do that, get rid of your percent sign. Find your decimal. If you do not see one, it's assumed to be right after the number, and you're going to move it over 2 places to the left. So your decimal would look like 0.06. Now that is your rate. To get our growth factor, it would be 1 plus that 0.06. So to write our equation, f of x equals 130,000, 1 plus 0.06 raised to the power of x. And x definitely should represent, we are growing in value 6% each year, so x represents number of years. So now I want to know how much is this house worth 10 years down the road. So I'm going to take my equation that I created, and I'm going to replace the x with 10. Okay, so into my graphing calculator I'm going to go. I'll use the older one for this one. 130, 1, 2, 3, 1 plus 0.06, parenthesis, up arrow key, parentheses, 10. And there's the value of my house. I did not tell you what to round to, so we'll round to the nearest whole number value on this case. 232, 810. So we'd say after 10 years, the house was worth approximately $232,810. And when you buy a house, you definitely hope that it appreciates in value versus goes down in value. All right, so again, if you get the idea, you're welcome to go on, pause the video, and just check your answers. If you want to listen to the other explanations, by all means, feel free to do so. But this is exactly what your classwork's going to look like and what your homework's going to look like. All right, number 2, poor Mr. McConaughey. He's losing 20% of his hair each year. Losing indicates that this is definitely going to be a decay problem. If he currently has 1,546 hairs on his head, approximately how many hairs will be left after 5 years? So he starts out with 1,546 hairs. This was definitely a decay problem. We decayed at 20%. So again, change that to a decimal. Get rid of your percent sign. Move your decimal 2 places to the left. So our decimal is 20%. Since it's decay, we would do 1 minus 0.20 to represent our growth or decay factor. So our equation, f of x equals 1,546, 1 minus 0.20 to the power of x. Important to represent 20% of his hair each year, so x represents number of years. You are welcome to simplify, by the way. You could take this and put it in your calculator, and it gets you 0.80, which is a number smaller than 1. Same with this one above. You could make that 1.06. You don't need to keep it as 1 plus or 1 minus. If you want to simplify, feel free to do so. So to answer our question, I want to know how much hair he's going to have left on his head after 5 years. I'm going to take my equation. Yep, notice I used the simpler form. Either one is fine. 1 minus 0.20 or 0.80. It's going to give you the same thing. We're going to replace our x value with number of years. And for our case, that's 5. So let's see how much hair he'll have left after 5 years, if any. 1,546, 0.80, raise to the power of 5, bring it on down. 506 hairs. We'll round that, give him the benefit of the doubt. So 506.59. So after 5 years, we can say Mr. McConaughey has maybe about 507 hairs still left on his head. All right, last one. The population of a small town is increasing. Well, there's your clue right there that this is going to be a growth problem. At a rate of 4% per year. If there are currently 1,341 residents, about how many residents will there be 5 years at this growth rate? Wow, even had the word growth in there, so I didn't have to assume that it one or the other. So our initial amount, looks like we have the population of Grantsburg. It's definitely growing, 4%. Change that to a decimal. 2 decimal places. Again, since it's growth, it's 1 plus that 0.04. So our equation, f of x, initial amount, 1 plus 0.04 raised to the power of x. X again represents, in this case, 4% per year, so this would represent the number of years. So how many residents will there be in 5 years of this growth rate? So we take our equation. I'm going to replace the x with number of years. So there would be 5. Again, grab a calculator, and you know Desmos, by the way, we'll do all of this same thing here for you. 1 plus 0.04, or you could write it as 1.04, raise to the power of 5, 1631.5, 53, and since we can't have a partial resident, we'll say 1632 people will be their new population. All right. So again, what's nice about the videos, you can go back now and you can listen or watch any one of the pieces that you want. And you can go back again and again as many times as you want. All right, enjoy.